Okay guys, as far as the placement of your servo horns, I put the rear servo horn so it is straddling over the fiberglass rod that goes on the Elevon. It's really close to the hinge line as far as the pull points on the horn. I usually put it at the top so you get the most amount of resolution. And then, you know, up at the very other end where the servo is, I usually go one hole up off the bottom of the airplane so it doesn't bind. And this gives you some good resolution. It allows you to use the servo in its motion and travel to where it's not binding against the airplane, and it gives you really good torque. So again, I usually use diagonal corners on the screws. You don't need all 4 screws. The other screw would probably hit right there anyways. These things are way overkill for servo horns anyways. And then on the bottom, the same thing on the bottom. You end up straddling the fiberglass on the bottom. And you know, I usually clip them off and then I put a dab of goop on the end of each one of those sharp ends of those screws that got clipped off. When I do lay it out, the first thing I do is I put the servo in. I hot glue the servo into the hole with a pool of hot glue on the very bottom, and then I run a bead of goop around it. And this is due to serviceability. If I want to take this servo out, I could either slice with the razor right around the top, and then stick a little alcohol on the bottom, and the servo pops right out. And then you can pull the rubber goop off later in the future if you need to do that. Or you can grab that goop with a pair of needle noses and you can pull it off, squirt a little alcohol on the bottom under the servo, and you pop it right out. But once you put the servo in, get your horn centered, stick it straight up, put your ball link on, and once you get the ball link on, take that measurement from the center of the ball link to the root of the aircraft, and then come out, and you can see I put a dot here, and that dot is the center of this when you're looking parallel to there. So if you can get this measurement from this edge to the center, come over to here and go from that edge to the center, and you mark it and then place it. It's real simple to do that. And then just use a regular pin vise or a very small drill bit with a drill to get that through there, and just do diagonal corners. So it gives you a quick, easy way to lay out the ball joints and get your rods straight. And then when these rods are being used, you can see this one here tilts just a little bit. This allows it to roll a little bit like it needs to. So the ball links are a good thing. When this airplane's flying, the airplane is only moving about a 1/4 inch up and a 1/4 inch down from its neutral point. So the articulation on this is, when you're flying, is about this much. So we're not worried about having these 90 degrees to the control surface. And the reason I don't do them 90 degrees to the control surface is because mechanically, yeah, it might be a little bit better mechanically, but this part of the airfoil, the air is coming in this way, it's swirling in, and it's hitting the fence. As it's hitting the fence, it's getting a very smooth flow of air across the control surface, and that's where your effective part of the control surface is and your elevator is. So now, if you take this and you run this at an angle across here, any of that air that's traveling in here to hit this wing fence is now getting disrupted across the airfoil. I'm trying to keep this airflow as it's coming in across here as straight and as linear as possible. So at this point, when it comes across, having these rods come back straighter, I've actually noticed the airplane handles a little bit better. And with the minimal amount of movement that this control surface needs to move, a little bit off angle is not going to hurt anything on this. So there you go.